All right, we're going to go over the constant multiple rule, sum rule, and difference rule of derivatives. They've given us two questions here. These both are pertaining, at least the first two, are to the constant multiple rule. And what they mean by that is we have some constant that we're going to multiply by after we find the derivative of it. If you remember, this constant just kind of stays to the outside, and we find the derivative of the function. So in the first case, we're going to find a derivative of x cubed. We've already solved x cubed as a derivative, but we will go through it again. So in this question, they ask us to find f prime x, which means I now take my 7 to the outside, and I find the derivative of x cubed. Well, the 3 now becomes the coefficient, so we have 3x, and 3 subtract 1 gives us 2, so we have 3 times x to the power of 2. I then multiply my constant term by the new coefficient, 7 times 3, which gives us 21x squared. That's it. F prime x is solved. Same idea with b, they want y prime. Okay? Remember I told you this can be written in different ways. Instead of using function notation, they're using type of graphing notation, so we're going to use y prime is equal to. Same idea, our constant multiple, our 12 comes to the outside, and we're going to derive our x to the power, that's supposed to be an exponent, to the power of 4 over 3. That 4 over 3 becomes our coefficient. And our new variable is technically equal to 4 over 3 subtract 1. Okay? We know that 1 is actually 3 over 3. So we get 4 over 3 subtract 3 over 3. Our new exponent is 1 over 3. We're not done. We do have to multiply. 12 times 4 over 3 gives us 48. Divide 3. 6. Thank you. 16 x to the power of, I'll write it sideways so it looks more like an exponent, a third. That's your constant multiple rule. It's very similar to the product rule. Only difference is when you bring the coefficient in front, you just multiply by the constant multiple or the original coefficient. Okay? That's a pretty straightforward one. We're going to go along. We're going to keep going. We're going to use the sum rule next. Okay? Sum rule. That's our fourth example. Sum and difference. Oh, okay. Let's do both. Sum and difference rule. Okay? They're going to give us two questions again. F at x is equal to 3x squared minus 5 root x. And y is equal to 3x plus 2 squared. Okay? The first one they've asked us for f prime x. So if you guys remember from the difference rule, what they said to do is find the derivative of the first term or the first function, find the derivative of the second function, and just keep that negative sign between the two derivatives. So we're going to derive our first function in red here. From what we know about our constant multiple rule, we're going to bring the 2 in and multiply it by the 3. So we're going to be left with 6x. And 2 subtract 1 just gives us 1, so it's to the exponent of 1, but we don't necessarily have to write that in because we know the exponent of 1 just keeps the same term. So derivative of 3x squared is 6x. We bring down our subtraction sign. And we're going to derive our second part. Now, our second part's a little harder, so I'm going to still work on this. We're going to do it in between. So I'll move this down a little so you can see there's a step or two in between here. Now, technically, this is 5x to the half. And according to our constant multiple rule, we bring this down. This now becomes 5 over 2. Okay? Let's move it over. When we multiply 5 times a half, we get 5 over 2 x. And 1/2 subtract the number 1 is actually negative a half. If you guys remember, we can represent that as a root on the bottom of a fraction. So we're going to end up with, okay, this is also equal to 5 over 2 multiplied by 1 over x to the half. I'm going to write the final answer down here. We get 5 times 1 is 5, over 2 root x. Okay? This is our derivative of the function. We'll write it all out in black here. So I know I did a lot of steps in between. But f prime x is equal to 6x subtract 5 over 2 root x. Okay? Just make sure you're aware of how to solve this. Oh, wrong one. How to solve this here as a derivative. That's what all these steps were. We essentially did 1, 2, 3 major steps to get to our final answer, even though I only wrote it in one line. Okay. That was a difference rule. If you notice, it's still subtraction between the two derivatives. Nothing big to that. We just derive first function, derive second function, keep a negative sign. Now I'm going to bring this one down a little because I'm going to need a little bit of room. That's 3x plus 2 squared. Okay. So y is equal to, this is B, question B, 3x plus 2 squared. 3x plus 2 squared. Now, in the next chapter, we're going to get into a rule with this, kind of like a chain rule here, but we're going to solve it using our sum derivative rule. In order to do that, I actually need to distribute everything first, so that I'm working with several sums, and then I'm going to derive those functions, okay? Because right now we don't know a rule to this. So this then becomes 3x plus 2 multiplied by 3x plus 2. When I use my distributive property, I get 9x squared plus 6x plus 6x, so it's going to be 12x plus 4. So I'm left with 9x squared plus 12x plus 4. Now I can use my derivative of sums rule to solve this. Remember, they said to just derive the first function, derive the second function, and then derive the third function. Okay? They actually said it with 2 terms, but this can be applied over numerous terms. It could be 8 different terms in this. And all we're going to do is bring down our addition sign between the derivatives of these. Okay? So, y prime will be equal to constant multiple rule. I bring the 2 over. 9 times 2 is 18. 2 subtract 1 is 1. So it's 18x. That's the derivative of the first one. Our second term, we're to the power of 1. When I multiply 1 by 12, what do I get? 12. But what's 1 subtract 1? 0. So what's x to the power of 0? Just 1. Okay. So our variable is actually going to disappear in this derivative here. And we're just going to be left with the coefficient in front, which is 12. And finally, this was our constant rule. What is the derivative of any constant? 0. So our y prime in this case is 18x plus 12. That's it. Okay? A lot simpler than it looked like it was going to be. So that is your constant multiple, sum, and difference rule all in one.